In this experiment, you'll study the motion of a projectile fired from a spring launcher by making a video of the trajectory and analyzing it in the tracker program. A large cardboard backdrop allows you to easily see the ball's position in each frame of the video. Because the acceleration, in this case that due to gravity, and the ball's initial velocity are not in the same direction, the ball's motion has to be analyzed in 2 dimensions, and there are separate equations describing the ball's motion in the x and y coordinate directions. To prime the spring launcher, place the projectile in the barrel and use the cylindrical plunger. The spring has 3 levels of compression, but the first is more than enough for use in the lab, and you should use this for all of your launches. A weighted string on a scale allows us to measure the angle of our initial launch. We'll begin with an angle of 45 degrees. We can analyze the video of the ball's path to determine the kinematic quantities like the acceleration of gravity and the initial velocity of the ball. Next, we point the launcher at a different angle. Now that we've determined the initial velocity of the launcher, we should be able to use the kinematic equations to predict the trajectory of the ball. Where do you think the ball will land? Use the equations to predict, and don't forget that the initial and final heights of the ball are not the same. Once you've made your prediction, analyze the video and compare the results. As always, multiple trials will allow you to determine more consistent values and eliminate random errors.